Okay. So I'm going to solve the problem in my way. That is, I have taken a small line element on here DL. So it is a very interesting problem because here the charge density varies with the theta. Okay. So next thing is okay. So in then first I will going to calculate the electric field at the center due to the particular line element because it contains charge dq. Okay, at O. So obviously there should be an electric field, and then we will integrate. So to get the electric field for the total semicircular arc. Okay. So dq is the elementary charge present in dl. So that is lambda into dl, right? So that is we know, and I have taken two components of this particular d. One is d cos theta is opposite to the x-axis, and d sin theta which is opposite to the y-axis. So vectorially, the electric field is d cos theta minus I cap and dE sin theta minus j cap. Okay. Okay. So let us solve this first. So that is minus. I am taking minus outside common. So that is cos theta I cap plus sin theta j cap. Fantastic. Good. So now we are going to calculate the integrate them out. So first of all, I am going to write that is k dq by r square in the place of dE. That is cos theta I cap plus sin theta j cap, right? And dq is lambda dl, and lambda is lambda naught, so sin theta. So I'm going to put everything here. So sin theta, lambda dl, so that is lambda. I have put first lambda naught sin theta, then dl is r d theta, then the factor cos theta I cap plus sin theta j cap, right? So we have to integrate it to get the total electric field. So total electric field, so the vector is must be equal to, so that is integration of this above quantity, but I'm keeping the constant factors outside the integration so that I can skip one line. So first of all, I'm just cancelling one power of r. So it becomes k lambda naught by r, and integration is cos theta I cap plus sin theta j cap to sin theta d theta. And integration limits, since it is the first quadrant and this is fourth quadrant, so integration limit must be, and theta becomes 0 along the x-axis. So it becomes minus, integration limit is minus pi by 2 to plus pi by 2. Good. So it is minus pi by 2 to plus pi by 2. And to deal with this integration, so it is very, very helpful to multiply the integrand by 2 and divide it all the things by 2 so that the integration remains same. It does not affect because the numerator is multiplied by 2. I am keeping the sin theta inside. So 2 cos theta sin theta I cap plus sin square theta j cap, right? Into d theta. Good. So now k lambda naught 2. So first term 2 sin theta cos theta is sin 2 theta, right? So minus pi by 2 to plus pi by 2 is sin 2 theta I cap. And the next term becomes 2 sin square theta, right? D theta. Okay. So sine 2 theta, sine any angle is a odd function of, it is a odd function of theta. And this is the even function because it is a square. So we have to apply now the property, very important property. So f is a odd function, minus a to plus a dx equal to 0. If f is a odd function, then the integration from minus a to plus a is always 0. Whereas for even function, the limit can be modified slightly to make our life easier. The limit can be modified. So this integration can be written for the event function. So f event dx minus a to plus a can be written as 2 into 0 to a f event dx. So this can be written out. Okay. So now it becomes minus k lambda naught. Just I'm using that. So the first is the odd function, and this is the even function. So for the first case, the first odd function, the integration becomes zero. So we are not bothering about the first function now. So we are bothering about the second function. So that is 2 sine square theta. And I'm going to modify it by, okay, so I'm first write this. Then I'm going to use this mechanism here, which is shown here. So I'm going to just changing the limit to 0 to pi by 2, 2 sine square theta. This is it. So 1 to cancel out. So it becomes k lambda naught by r minus. So it becomes, okay, uh, yes. And 2 sine square theta can be written as 1 minus cos 2 theta. This theta. Okay. Okay. So it is your home task to check that this integration cos 2 theta d theta in this limit 0 to pi by 2 is 0. Okay. So this part is 0. Only the first part is giving a non-zero value, which is actually the pi by 2, and it should be multiplied with j cap because we are dealing with the j cap here only. Yes. So the final answer is, so I'm now putting the k explicitly because it is needed to match with the answer. So pi cancel out. So lambda 8 epsilon naught r j cap. So it is a negative sign. So why is it happening? Electric field is along the negative z axis. So if I analyze the picture again, because we have already find the electric, we have already found the mathematics, we have already found the answer. Then our task is to actually analyze the picture. Okay. So here, that is since it is a lambda equal to lambda naught sine theta, then the upper here the all the angles for this first quadrant, all the things are positive. That means here all the charges are positive quantity. Okay. So the in upper part, so all the charges is positive one. But in lower, since it is a fourth quadrant, so sin theta value is negative. So here is all the charges are negative. So the electric field at along at this position is actually, if I keeping the plus one charge here, so all the positive charges are push the plus one charge in this direction, and negative charge is pulling also in this direction. So that is why the resultant electric field is along the negative y-axis. That is why you have actually found the electric field along the negative x-axis. So this is the final answer. Okay.